the next session on ANSYS CFD tutorials. In this session, we will analyze the Orifice Meter for its fluid flow analysis. We will start by double-clicking on Fluid Flow Fluent. I will right-click and import the geometry since I already have the geometry made with me. Now I'll again double-click on geometry because I want to add the fluid here. You can first see that this is two parts, two bodies. I will first go to create Boolean. I will unite both these bodies as one. So I'll select both the solids, apply and generate. Now you can see it is one part, one body. So I'll go to tools, fill option. Wherever I want to add the fluid, I will select all those surfaces by pressing the control button. Apply and generate. Now you can see this is one solid, which is the outer one. So I'll call this as wall. And this is the inner one. So let me call this as fluid. You can see the entire pipe is filled with the fluid. So once this is done, we'll close the geometry. Then I'll go to mesh and double click. I'll first go to mesh. I'll change the element size to 0.01 meter and generate. Once the meshing is done, I will label this side as the inlet. So I'll right click, create named selection. This is the inlet. This side, right click, create named selection is the outlet. And this is the wall. Now you can call this as wall or you can call this as pipe. That's also fine. So here you can see inlet, outlet and pipe is what I've created. Then I'll go to mesh again and update. This message is important. The mesh translation to Fluent was successful. Now I'll close this window. I'll go to setup and double click. I will click on start. I'll first select gravity. Along the y-axis, I'll give the value as 9.81 meter per second square. Then I'll go to materials, fluid. I'll double click on air. I'll click on Fluent database. It is asking for the material type, which is fluid. I'll select water liquid, copy and close. Then I'll go to solid and double click on aluminium. I'll select Fluent database. I'll change the material type to solid. Let us say that the pipe is made of steel. So copy and close. Once we have added the materials, we'll go to cell zone conditions. I'll double click on fluid. I'll go to material name. I'll select water liquid, apply and close. Then I'll go to solid and double click on wall. I'll select the material name as steel, apply and close. Then I'll go to boundary conditions and double click on the inlet velocity. I'll give the velocity magnitude as 2.5 meters per second and apply and close again. Once we have given the boundary conditions, we'll go to reference values. Here I'll compute from inlet. Reference zone is the fluid. Then I'll go to initialization and double click. I'll select standard initialization. I'll compute from inlet and click on initialize. Next, I'll go to calculation activities and double click on autosave. Here I'll select 30. Okay. Then I'll go to run calculations and double click. Number of iterations I'll select as 500 and calculate. So the calculations are complete. Now you can see here the solution has not converged. Here also you can see the solution is still iterating. But we will end it here itself. Next I'll go to results and double click. Now I click on inlet and then I'll go to render and choose transparency as 0.9. I'll do the same for outlet, pipe and wall. So once this is done, I'll click on streamline. Okay. I'll start from inlet. Number of points, let me choose as say 100. Then I'll click on apply. So you can see here, this is how the streamline is going to be. Now I'll click on animation to see the motion of the fluid. I'll select type as sweep animation. Streamline 1. I'll remove the forever loop. I'll repeat 3 or 4 times. We can set the speed to fast or slow and then play. This motion of fluid is quite fast, so you can reduce the speed and play again. So I have reduced the speed. Also size of these particles were quite large, so I'll click on options. The symbol size you can see is 1. I'll make it to 0.6. Okay. And then play once again. Now you can see it's moving slowly. It will be at a particular speed over here. But when it comes to this orifice end, the velocity is going to be fast. And that's how you can see the speed increases after it passes through this orifice. Now the maximum velocity over here, as you can see, is 2.1 into 10 raised to 1. That is 21 meters per second. And minimum is 1.08 into 10 raised to minus 1, which means it is 0.1 meters per second. So it's quite low. Now this is all about the streamline. Once this is done, I'll tick over here. I'll remove the tick. Then I'll click on contour. Okay. I will select the location as contact region TRG. We want to see the pressure. Range is local. Number of contours is 11. You can change it to say 25 or 50, whatever you want. I'll go to render and remove the show contour lines. I'll go back to geometry and apply. So you can see here, this is how the pressure contour is going to be. Here the pressure is 1.79 into 10 raised to 5 Pascal in this zone. At the orifice end, you can see the maximum variation of pressure. And again, the pressure is going to increase. Here the pressure is going to be minimum at the orifice end. In fact, it is minus 106,834 Pascal, which means it is vacuum over here. And on the other two ends, that is a pipe end, you can see it is positive. Again, I'll remove this contour 1. I'll click on contour once again. I am creating the second contour now. This is of velocity. Range is local. I'll give number of contours as say 25 or 50 or 100, whatever you want you can give. I'll select the contact region TRG as the location. I'll go to render and remove this show contour lines. Go back to geometry and apply. So here you can see the velocity distribution. The highest value is 14.32 meters per second and the lowest value is 0.21595. Now the highest will be over here. You can see in this zone. The reason is because it is sudden change in diameter. So here the velocity is going to increase as the diameter is less and the pressure is going to reduce. And here you can see the velocity is less in the other two ends. Here the pressure is going to be more. So that's how you analyze an orifice meter using CFD analysis for its fluid flow. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.